Welcome to this deep dive into cybernetics, a field that I'll admit sounds a bit, technical at first.
Yeah.
But trust me, there's a lot to uncover here. You sent in a pretty diverse collection of materials for this one, some older, some newer. So it seems you're already sensing how these ideas, even from way back, still have a lot to say to us now.
What I find fascinating about your selection is that you're not just treating cybernetics as a historical thing. You're clearly interested in how it connects to the world today.
Exactly. We want
Yeah.
to dig into those core concepts and really see how they apply to, well, everything from how we communicate to the role technology plays in our lives. So, first things first, what exactly is cybernetics? It's not exactly a word you hear every day.
Right. Cybernetics isn't exactly, dinner table conversation.
Yeah.
At its heart, though, it's the study of how systems, and this could be anything, a machine, a living being, even a whole society,
Wow.
communicate, control themselves, and adapt.
Yeah, okay. That makes sense. And this idea of feedback seems to be a key concept that pops up a lot in these materials.
Absolutely. Feedback is essentially information that a system, any system, gets about its own actions, which it can then use to change or improve. Like when you're driving, you're constantly making tiny adjustments to the steering wheel based on what you see on the road.
Right.
That's feedback in action, helping you stay on course.
I see. So it's like a way for systems to learn and self-correct. Now, one person who really stands out in all this is Norbert Wiener, a mathematician working on these ideas during World War II. It struck me how much he seemed to predict about how technology would change everything.
Wiener was way ahead of his time. He wasn't just focused on the technical stuff. He was thinking about the social and even ethical side of these advances. He saw that technology could be used for good or bad. And he really stressed the need for, well, a conscience to guide its development. Like, he was really worried about automation causing widespread unemployment and argued that we need to figure out how to share the benefits of technology more fairly.
So he was saying basically that we can't just blindly adopt new technology without thinking about the consequences. We need to be mindful of its impact on society as a whole.
Exactly. And that message, well, it couldn't be more relevant today, could it?
No, not at all. All right, let's tackle something that might seem a little abstract at first, but is super interesting. We have this concept from physics, the second law of thermodynamics, which is all about entropy. Now, I'm no physicist, so break this down for me. How does this law, which seems to be about the physical world, tie into information and cybernetics?
Right. Entropy can sound intimidating, but it's a pretty simple idea, really. Systems tend to move towards disorder over time. Think of a perfectly organized bookshelf.
Okay.
If you don't, you know, actively tidy it up, it's going to get messy, books out of place, dust collecting.
Right.
That's entropy at work.
So everything's kind of on a one-way street to chaos.
Oh, and a closed system, yeah.
Right.
But here's where the connection to information gets really cool. Think about a message being transmitted, like a text message you send to a friend. If there's any interference, a drop signal, a typo, anything that messes with the original message, that's an increase in entropy. The information gets less clear, more distorted.
Like static on a phone line, making it hard to hear the person on the other end.
Exactly. And that idea that information loss is connected to entropy. It's key to understanding the challenges of communication, especially in complex systems.
Yeah.
It's not just about sending a message, it's about making sure that message gets received correctly. This applies to everything, from computer networks to relationships between people.
It really is a different way to think about it. It kind of makes you realize how delicate communication can be, how easily messages can get lost or distorted.
Exactly. And it highlights the need to design systems, any systems, that are robust enough to handle those distortions and ensure that the right information gets through.
Okay, so we've got this foundation of cybernetics with its focus on communication, control, feedback, and now this unexpected link to entropy. But then you brought up this, well, rather unusual comparison, humans versus ants. I have to ask, how do ants fit into this?
Well, it might seem like a strange pairing, but it's a great way to think about the relationship between structure and adaptability.
Hmm.
Picture an ant's exoskeleton, right? It's rigid, it's protective, but that same shell limits how much the ant can grow and change.
Like a suit of armor,
Right.
great for defense, not so much for flexibility.
Exactly.
Right.
And compare that to the human body, where, well, we're soft and squishy. But that's what allows us to grow, to heal, to adapt to different places. And this difference in our physical structure, it's directly related to our capacity for learning and communicating.
So the ant, with its rigid structure, is kind of stuck in a pre-programmed role.
Exactly. It has limited capacity to learn or adapt as an individual. Humans, on the other hand, have much greater potential for growth and change because our physical structure is so flexible. And this goes to the heart of what cybernetics asks. If we're designing machines to be more intelligent, how do we avoid building those same limitations into them? How do we create systems that are adaptable, that can learn and change over time?
It makes you think about the design of AI, right? And whether we're accidentally creating systems that are too rigid, too limited in their ability to learn and adapt.
That's exactly the kind of question cybernetics pushes us to ask.
Okay, so we've gone from ants to artificial intelligence, and I can see how these seemingly totally different ideas are starting to connect. It's about understanding systems, their limits, and their potential. But what about language? How does that fit in?
Language is such a fascinating system. Complex, highly structured, yet incredibly flexible is how we share information, express ourselves, connect with each other. But there's a curious thing about language, actually directly related to the concept of entropy we talked about earlier, the phenomenon of cliches.
Okay, I'm all ears. Tell me about cliches and how they relate to entropy.
Imagine a phrase that was once fresh, original. Maybe a metaphor or a witty saying.
Yeah.
As it gets repeated over and over, it loses its punch, its originality, this information value.
Right.
It becomes predictable, almost like background noise. Like, think of a song you've heard 1,000 times.
Yeah.
You know exactly what's coming. There's no surprise.
So the information content of the phrase has kind of degraded over time.
Exactly. And that degradation, that's a form of entropy. The message has become less clear, less informative.
Cliches are like linguistic entropy. That's an interesting way to put it.
And it brings up these really interesting questions about how we value information, especially now when everything's constantly being copied and shared.
Okay, I see where you're going with this. You're talking about copyright, intellectual property, that whole debate about how to protect creative work in the digital age, right?
Precisely. On the one hand, we want to encourage information to flow freely, to make knowledge available to everyone. But on the other hand, you also want to give creators incentive. You want to protect their work, ensure they're rewarded for it.
Yeah, that is a tough balance. And technology seems to be making it even harder.
It really is. The ease with which we can now copy and share information online has, well, it's totally disrupted the old models of copyright and intellectual property. We're still figuring out how to adapt those models to the digital world, how to design a system that both encourages creativity and keeps information accessible.
It's like we're rewriting the rules of the game as we go along to try and match the realities of the digital world.
That's a great way to put it. And it's a conversation we need to have to shape how creativity, innovation, and sharing knowledge will look in the future.
Okay, so we've gone from entropy to cliches to copyright, and I'm starting to see how these seemingly totally random ideas are all connected by this thread of information theory. But now I'm curious to shift gears a bit and explore how cybernetics connects to the Industrial Revolution.
This is where we really see how technology and society, they push and pull on each other, often in unexpected ways. One parallel that people often miss is the invention of accurate chronometers. They revolutionized navigation long before the steam engine kicked off the whole Industrial Revolution.
So a technological leap in one area can have ripple effects in places you wouldn't even expect.
It really shows how interconnected these technological leaps are. Now think about the steam engine and how it changed factories. Early factories, they were all designed around these big, centralized power sources. The steam engine was powerful, but it had to be in a fixed location, and everything else had to be built around it.
Which led to huge social and economic shifts. People had to go where the factories were, cities became more crowded, and work was totally transformed.
Absolutely. But then something interesting happened. The electric motor and the vacuum tube, those inventions, they changed everything.
Yeah.
Power could be decentralized. You didn't need massive steam engines to run a factory anymore. Smaller, more spread out power sources became possible.
So it's like these new technologies opened the door to a different kind of industrial revolution.
Exactly. It paved the way for what some historians call the Second Industrial Revolution. It's still happening, but it has the potential to be just as transformative as the first one, changing the way we work and live in fundamental ways.
Okay, I can see how this ties into the ideas we've been talking about. Adaptability and flexibility. It's like technology is constantly creating new possibilities, new ways of organizing ourselves, and of course, new challenges to face.
That's a great point. And it leads us to one of the biggest challenges we face right now, the rise of automation.
Ah, yes, the robots are coming.
It's a topic that causes a lot of anxiety, that's for sure. How does cybernetics help us understand this?
Automation is, at its core, the application of cybernetic principles to, well, to work.
We're building machines that can do tasks that humans used to do, often more efficiently and accurately. And this has massive consequences for the future of work itself.
So are we all going to be out of jobs?
It's not that straightforward.
Yeah.
Some jobs, yeah, they'll be replaced.
Right.
But new jobs will also be created. The key is to be proactive, to adapt our skills, our education systems to this new world.
So it's not about trying to stop automation, it's about figuring out how to manage this transition in a way that works for everyone.
Exactly. And cybernetics gives us a framework to think about the future of work.
Right.
I think it's important to remember, picking up where we left off, that automation isn't like this unstoppable force that's just going to happen to us.
Right.
It's a choice, a technology, something we develop and put into action, which means we have to be responsible about how we use it.
So it's not about whether it'll happen, but about how we steer it, how we shape how it affects society.
Exactly. And a big part of that is, I think, education and training. We can't just leave people behind as technology moves forward. We have to invest in programs that help people build the skills they need to succeed in this future where automation's everywhere.
It's like we need to constantly be learning, constantly be adapting to how the job market's changing.
Absolutely. Another thing to consider is, well, how do we spread the benefits of automation around? If machines are doing more of the work, who gets the rewards? We got to make sure those benefits are shared fairly and that everyone has the chance to be part of the new economy, whatever that looks like.
It makes me think of all the talk about universal basic income, which seems to be gaining some momentum as we think about the future of work.
It's definitely a possible solution, but not the only one. The point is, we need to be creative. Think outside the box and be willing to try different approaches. We got to have a real conversation about what a fair and just society looks like, in this age of automation.
It sounds like we're not just talking about economics anymore, but about like ethics, values, what kind of future we actually want to build.
Exactly. And that's where cybernetics comes in. It gives us this way to think about these complex issues, to see the trade-offs and make informed choices.
Okay, I'm seeing how cybernetics isn't just about the technical side of machines. It's really about systems, human systems too, and how they all interact.
Exactly. And one of the coolest things about cybernetics is how it shows just how connected everything is. What we do in one area, be it technology, politics, economics, even art, it has a ripple effect on the whole system.
Like the butterfly effect, right?
Yeah.
A tiny change in one spot can have huge consequences somewhere else.
Exactly. Cybernetics helps us see those connections, understand that bigger picture, and really grasp how complex the systems we're dealing with really are.
As you're talking, it's hitting me that this deep dive, it's not just about cybernetics, it's about like systems thinking as a whole. It's developing a new way to see the world where you recognize how connected everything is.
That's a great observation. Cybernetics is a big part of systems thinking,
Right.
but it's not the whole story.
Right.
Systems thinking is this wider framework encompassing like tons of different fields and approaches.
Yeah.
But that core idea is the same. Understanding how things work together, how they affect each other, and how we can step in and make positive changes within those systems.
Okay, I'm really seeing how valuable this way of thinking can be. It's like a new lens to look at the world through, to make sense of all the complexity and see like patterns that you might not have noticed otherwise.
Precisely. And that's what makes this deep dive so fascinating. It's not just about learning facts. It's about growing our capacity to really understand.
All right, so we've talked about like abstract concepts and theoretical stuff, but are there any real-world examples that can, bring these ideas down to earth a bit?
Absolutely. In fact, cybernetics is all around us, whether we realize it or not. Think about the Panama Canal. It's this marvel of engineering, but it's also a perfect illustration of cybernetics in action.
I'm not sure I follow. How's a canal related to cybernetics?
Well, the Panama Canal is this intricate system, right, of locks, dams, channels. It lets ships move between the Atlantic and Pacific Oceans. And what makes it work is a super sophisticated network of feedback and control mechanisms. They're like governing every single function of the canal.
So it's not just a static thing. It's dynamic, constantly adjusting to the changing conditions.
Exactly. The water levels in the locks, they have to be precisely controlled. The traffic flow managed. Any hazards have to be spotted and dealt with right away.
Yeah.
And all of that happens through a network of sensors, actuators, control algorithms, all working together, constantly monitoring and making tiny adjustments as needed.
It sounds like a giant real-life feedback loop.
That's a great way to put it. And it shows just how vital these feedback mechanisms are for any complex system to work. Could be a canal, a city, even, the human body.
Okay, I'm starting to see how these abstract ideas from cybernetics actually play out in the real world.
And it's not just the Panama Canal. These principles are everywhere. Managing traffic in cities, regulating the temperature in your house, you name it. Cybernetics is all around us, shaping our lives in ways we often don't even realize.
So it's not just some like niche theoretical field. It has practical uses that affect all of us every day.
Absolutely. And the more we understand these principles, the better we can design, manage, and interact with all these complex systems that make up our world.
Okay, this is starting to click for me, but I'm still a bit curious about this second industrial revolution. You mentioned it earlier, but I'm not sure I fully get it.
It's a term that describes the shift from mechanization, using machines to replace, muscle power, to automation, where machines are doing tasks that require intelligence, making decisions, solving problems.
It's like we're moving from brawn to brains.
That's a great way to put it. And what makes this shift possible are cybernetic systems. Systems that can process information, learn, and then make decisions based on data.
So cybernetics is like the engine driving this second industrial revolution.
In many ways, yes, because it provides both the theory and the actual tools to create these intelligent machines.
Okay, that makes sense. But what does this second industrial revolution mean for us? How will it change how we work, how we live, even how we think about ourselves?
Those are the big questions, aren't they? And there are no easy answers. But one of the most significant impacts will be on work, on jobs. As machines get better at doing tasks that used to need human intelligence, lots of jobs are going to change. Some will disappear altogether.
So are we all going to be out of work?
Not necessarily. New jobs will pop up, and the nature of work itself will transform. We'll have to adapt, pick up new skills, and be ready for a job market that's constantly in flux.
It sounds like we're sailing into uncharted waters. Could be a bumpy ride.
That's one way to look at it.
Yeah.
But it's also incredibly exciting. We have this opportunity to reimagine what work is, to invent new ways of doing things, and to build a society where everyone has the chance to contribute and to flourish.
So instead of being scared of automation, we should see it as a chance to rethink how we live and work.
Exactly. And cybernetics can help us navigate this transition by giving us tools to understand how these complex systems work, to anticipate problems, and to make smart choices about the kind of future we want.
Okay, I'm starting to see how everything connects, but I gotta admit, I'm feeling a bit overwhelmed by the sheer scale of all this. It's like we've opened this Pandora's box of ideas, and I'm not sure where to even start making sense of it all.
That's understandable. Cybernetics is a huge and challenging field. The trick is to take it one step at a time.
As we talk, I keep circling back to this idea of information. It seems to be at the heart of so much of what we've been discussing. But information itself, it's this weird concept, isn't it?
Yeah.
Intangible, but so powerful, it shapes our world. How do we even begin to understand something as slippery as information?
That's a fantastic question. And it's one that philosophers and scientists have been wrestling with forever. But cybernetics does offer some valuable insights. One key thing it shows us is that information isn't just some abstract thing floating around out there. It's always part of a system, always flowing through it in a specific way.
So it's not just what information is, but how it moves, how it's used, how it affects, how that system behaves.
Exactly. And by understanding that, how it all works, we can start to get a handle on the power of information, how it can be used to control things, to influence behavior, to shape what happens.
This makes me think about all the debates about data privacy, surveillance, and how our online activity is being tracked and analyzed.
Those are crucial issues, and they highlight why we need a better grasp of information and how it impacts our lives. Cybernetics gives us the tools to start asking the right questions, to see the links between things that might seem unrelated, and to think critically about how we want information to work in our society.
Okay, I'm seeing how it all goes back to that systems thinking idea. It's about seeing the whole picture, how information flows, and what those flows mean for us.
Precisely. And one of the most interesting things about information is that it's constantly in motion, changing, evolving, degrading. Remember we talked about entropy?
Right, the idea that systems tend towards disorder.
Well, that applies to information too. Every time it's copied, transmitted, processed, there's the risk of it being lost or distorted. It's like making a photocopy of a photocopy.
Yeah.
The image gets fuzzier each time.
So information is kind of like a valuable resource that we have to be careful with.
That's a great analogy. And it shows why it's so important to design systems that protect information, that keep it accurate, and make sure the right information gets to the right people at the right time.
This makes me think about how hard communication can be,
Yeah,
how easy it is for messages to get lost or misunderstood, and how important it is to be clear and concise in how we communicate.
absolutely. And it also shows why we need to be critical thinkers,
Yeah.
to be able to assess the information we come across, figure out what's reliable, and not be swayed by, misinformation or propaganda.
So cybernetics isn't just about machines and systems, it's also about human psychology, about thinking critically and how we make sense of the world around us.
That's a great point. Cybernetics draws on insights from everywhere. Engineering, biology, psychology, sociology, you name it. It's about understanding that complex dance between humans, machines, and information.
Okay, it's all starting to come together, but I gotta say, I'm also a bit, well, overwhelmed by how much there is to it. It feels like we've opened this huge door, and I'm not sure where to even begin with it all.
It's totally understandable. It's a big, challenging field,
Mhm.
but the key is to just take it one step at a time.
As we've been talking, I keep thinking about the ethical side of all this. We're talking about powerful technology here, stuff that could fundamentally change our world. How do we make sure it's used responsibly, ethically, and for the good of humanity?
That's the million-dollar question, isn't it? And it's not just for scientists and engineers to answer. Policymakers, business leaders, everyday people, we all need to be thinking about it.
Yeah.
We need to discuss what values should guide how this technology is developed and used.
So it's not just about whether we can build it, but about the context, the social, ethical, political landscape where it's being created and put into use.
Exactly. And that's another place where cybernetics can help. It gives us a framework to think through these complicated issues, to understand the choices we make, and to make decisions that are informed.
Okay, I'm seeing how cybernetics is more than just a field of study. It's a way of thinking, a way of seeing the world, and a call to action. It's about recognizing the power of systems, the importance of feedback, and the need to shape technology so that it serves us, serves humanity.
That's a fantastic summary. And it highlights why cybernetics is so relevant right now, as we face all these unprecedented challenges and opportunities in this age of AI, big data, and, global interconnectedness.
Well, I think we've covered a lot of ground in this part of our deep dive.
We have.
I'm starting to feel like I'm getting a handle on these ideas, but I also know there's still a lot more to explore.
That's the beauty of it. There's always more to learn, more connections to make, and more insights to uncover.
Okay, well, I'm looking forward to continuing this exploration in the final part of this deep dive. Picking up where we left off, I'm still kind of grappling with that idea of, balancing individual freedom with what's good for the group. You mentioned that cybernetics can help us see both sides of that.
It really can. It's a tension that's always been there in human societies. We cherish our individual freedom, our right to make our own choices, but at the same time, we know we're all part of this larger whole, and what we do affects others.
Like no man is an island.
Exactly.
Yeah.
Cybernetics gives us this way to understand how those individual actions, they contribute to those bigger outcomes,
Hmm.
and how we can build systems that balance individual needs with the well-being of everyone.
So it's not about picking one or the other. It's about finding ways to bring them together to design systems that work for everybody.
Exactly. And one of the key insights from cybernetics is that the systems that work best are the ones that give individuals power while also encouraging, collaboration and people working together.
So it's not about control then, it's about enabling people.
That's a great way to put it. It's about building systems that give people the information, the tools, and the freedom to make choices that are good for them and for the greater good.
Yeah, that makes sense. As we've been talking, I keep thinking about that idea of language as a game, which you mentioned earlier. Can you unpack that a bit more? It still seems like a kind of strange way to think about something as basic as communication.
It might seem odd at first, but when you think about language as a game, it can actually be pretty insightful. Think about it this way. Every game has rules, players, and a goal, right? Well, so does language.
Okay, so what are the rules of the language game?
The rules are all those conventions we have, the grammar, the syntax, the vocabulary, all the stuff that governs how we structure our sentences and how we use words to mean things.
And the players, those are the people communicating.
Exactly.
Yeah.
And the goal is to reach some kind of shared understanding, whether it's to share information, express how we feel, build relationships, or even, to persuade someone to see things our way.
So it's like we're always kind of negotiating what things mean, trying to figure out what the other person's saying and what they really mean by it.
Exactly. And that's where the game aspect comes in. We're all trying to follow the rules, but we're also trying to use language strategically to achieve our own goals.
It's like a game of chess, but with words instead of pieces.
That's a great analogy. And just like chess, there are different skill levels, different strategies, different ways to come out on top. Some people are more eloquent, more persuasive, just better at using language to get what they want.
It makes me think about all the ways we use language, from casual conversations to, political speeches to advertising.
And each of those situations has its own set of rules, its own strategies, and its own goals, right?
Right.
So in a way, we're always switching between different versions of the same game.
It's a really fascinating way to think about it, and it makes me much more aware of how strategic language can be, how it's not just about conveying information, but about, influencing and persuading people too.
Exactly. And that's why it's so important to be, well, a critical listener, to be aware of what's not being said directly, the hidden messages and the potential manipulation that might be going on underneath.
It's like we need to develop a language radar or something to spot those hidden meanings and agendas.
That's a great way to put it. And I think that's one of the biggest things to take away from all this, from this deep dive, to become more aware of the power of language and how it can be used to shape how we think, what we believe, and what we do.
Okay, I'm definitely going to be paying closer attention to the language game from now on. But changing gears a bit, something else that really struck me from all this material was this idea of how limited mechanical systems are compared to biological ones.
That's a really important distinction in cybernetics. We're fascinated by this interplay between the world of machines and the world of living things, how they're alike and how they're different.
So what are some of the key differences?
Well, one of the biggest is adaptability. Like we talked about before, living organisms are amazing at growing, changing, adapting. Our bodies heal themselves, our brains learn new things, and we can, change how we act based on what we experience.
It's like we're constantly evolving, both physically and mentally.
Exactly. Now compare that to a typical machine. Machine is designed for a specific job, and it's usually pretty limited in how well it can adapt to new situations or learn from mistakes.
So a machine is kind of set in its ways then.
To some degree, yeah. And that can be a real problem when the environment changes or when the machine has to deal with something it wasn't specifically programmed for.
I see. So a machine's good at what it's good at, but not so good at, like, thinking outside the box or dealing with the unexpected.
That's a good way to put it. And that's one reason why cybernetics is so interested in feedback mechanisms. Because feedback is what lets machines learn, adapt, and become more flexible and responsive to changing conditions.
So feedback's the bridge between, like, the rigidity of machines and the adaptability of living things.
Exactly. And it's one of the biggest challenges in artificial intelligence. If we want to create machines that are truly intelligent, they need to be able to learn from their experiences, adjust what they do, and solve problems they've never seen before.
It's like we're trying to make machines come alive,
Wow.
to give them some of the same qualities that make us human.
That's a beautiful way to put it. And it's a fascinating challenge that's really pushing the boundaries of both science and philosophy.
Okay, I'm starting to see the philosophical side of this now, but can you give me like a more down-to-earth example of how feedback's used in designing machines?
Of course. Let's go back to the anti-aircraft gun example. That's a classic illustration of how feedback can make a machine work so much better.
Okay, remind me how the anti-aircraft gun connects to feedback.
Well, in the early days of anti-aircraft warfare, gunners had to, rely on their own judgment and skill to aim and shoot at these fast-moving planes. It was really hard and usually pretty ineffective. But as radar and computers developed, it became possible to build automated systems that could track how the planes were moving and predict where they were going.
So machines were taking over some of the work that humans used to do.
Exactly. And the key to making these systems work was feedback. The system would constantly be checking where the plane was and adjusting the aim of the gun accordingly.
So it was like this constant loop of observing, adjusting, and correcting.
Exactly. And it led to a huge improvement in how accurate and effective the anti-aircraft fire was.
Okay, so feedback isn't just about making machines smarter, it's about making them more effective and more capable too.
Precisely. And that has implications for, well, for so many fields, from manufacturing and medicine to transportation and beyond. Feedback is crucial for creating machines that can do these complex tasks reliably and accurately.
It's all starting to make a lot more sense. But as we wrap up this deep dive, I'm left with this one last question that keeps coming back to me. In a world where machines are getting smarter and smarter, more and more capable, what does it even mean to be human? What separates us from the machines we're building?
That's a deep question, and honestly, I don't think anyone really has the answer. But cybernetics, it does offer some hints. By studying how systems, both biological and mechanical, communicate, learn, and adapt, we can start to understand better what makes us uniquely human.
So it's not about drawing like a hard line between us and them. It's about understanding the spectrum of intelligence and seeing how we're both similar and different.
Exactly. And maybe in exploring those similarities and differences, we can learn more about ourselves, about what it really means to be human in this age of intelligent machines.
Wow, there's a lot to unpack there. I think this deep dive has really given me a whole new way to look at technology, at society, even at myself. Thank you so much for sharing your expertise with me.
It's been my pleasure.
And a huge thank you to our listener for sending in these thought-provoking materials that got this whole conversation started. We hope you found this deep dive as enlightening as we did. Until next time, keep exploring, keep asking questions, and keep learning.